Howdy, how's everybody doing? Today I want to go over the 2019 Calculus Free Response question number 1. It was the same question for both the AB and the BC test. So here we go. It's another one that I put into the category of interpreting rates of change. All right, we've got our model of fish entering a lake given by this function right here, and our model of fish leaving the lake with our model right here. Both those functions, E and L, for entering and leaving, are measured in fish per hour, and T is measured in hours since midnight. Any other extraneous information on here? I don't see any. We don't know how many fish are in the lake at the beginning, so I take it it's not going to be an issue. All right. How many fish enter the lake over the 5-hour period? So for entering, we're given the rate at which they're entering, which is E. So in order to figure out the amount, we just take the antiderivative of the E function from 0 to 5, and we just plug that into our calculator. Make sure you are in radians and not degrees. That's a big deal right there. And when you get that, you get 153.458. And it says answer to the nearest whole number, so we have 153 fish that have entered the lake since midnight to 5 o'clock. All right. Question B, the average number of fish that leave the lake over that 5-hour period. All right, so the average that leaves, we know the amount of fish that leave would be given by this. So that's the total number of fish that leave the lake between 0 and 5. So our average is going to be that. We're going to divide that by 5. It's going to be 1/5 of that. And that will yield us our answer. And again, put that in a calculator, you get for this 6.059. And that's the average number of fish that leave the lake between midnight and 5 a.m. If you remember, the average value of a function formula was given by this. So this is the formula that we're using here. Right. All right, question C. At what time is the greatest number of fish in the lake? So I'm going to write the expression, this helps me out, for the amount of fish that are in the lake. And we can call that anything we want. We'll call it, I'll just call it A for amount. The amount of fish in the lake is given by the number of fish that enter the lake to a certain time. We don't know that time. Subtracting the number of fish that leave the lake. So when we take this derivative, because if this is the amount, we want to take the derivative to find the maximum. So the derivative of an integral is just the original function. So this is what we're looking for. So we want to find a critical number. And really, it kind of makes sense. To find the greatest number of fish in the lake, the first value we have to find out is where does the rate of the amount of fish entering the lake equal the amount of the fish leaving the lake. So that solves this equation. I want to know if or when this is true. And that value would be at 6.204. So a little after 6 a.m. in the morning. And we want to know the greatest number of fish. So there's two things we can do. I can prove to you that that's a maximum, and that would show it's the greatest number of fish. Or I can use the absolute maximum ideal of testing the endpoint and seeing where I have the most fish. That's totally up to you. I like to do it this way. I like to say that at 6.204, if I test this derivative, I know that the fish before 6 in the morning, that there was more entering than leaving, and then after 6 hours, there were more leaving than entering, so that's a maximum up to down. Now, that's not a good justification for it. That's just my way of seeing it. So I know that the greatest number of fish occurred at 6.204. That time equals 6.204. Because the amount was increasing before, I'm going to move down a little bit, 6.204, and decreasing after. If you look at the rubric that AP sent, they do it both ways. They do it as showing that it's a maximum. They also show it as testing the endpoints and finding the absolute maximum. And both ways are fine. All right, part D. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? So be careful of all the words. What is the rate of change in the number of fish? I mean, that's given to us. We know the rate entering is given by the function of E, and the rate leaving is given by the function of L. That's the rate of change in the number of fish. If I want to know if it's increasing or decreasing, I analyze the derivative of this. Because the derivative will tell me if it's increasing or decreasing. So if the derivative is positive, it's increasing. If the derivative is negative, it's decreasing. So I simply, in this particular case, I'm just going to plug in the values of 5. And I find out that the value is negative 10.722, or 723, I think it rounds to 723. Well, it's negative, so that means the rate of change of the number of fish is decreasing at 5. And the reason would be is because the rate entering is less than the rate leaving. Okay? Or you can just say decreasing at 5 because E prime of 5 minus L prime of 5 is less than 0. So just be careful with the wording. The question itself really isn't that crazy. It's the wording that makes them difficult. There you go, 2019, and have a good day. I'll see you later with some more problems. Bye.